Hello everyone, my name is Lokesh, son of Kumaraguru, from the class RY31. My matric card number is 211291003. Today, I am here from group number 14 for the mini project called the Management and Evaluation of Transmission Line Project. Let me introduce my teammates, Navanidan Anandalaki Guniraj, Dinesh Raj Anandalaki Govindaraju, and Noran Fatiha binti Norazman. Okay, let us move to the introduction slide. Okay, this is a case study of construction of 275 overhead line with 1000 megawatt capacity from Rawang to Kuala Lumpur. Okay, so the significant transmission line project is to ensure stable condition and efficient and reliability throughout the project life cycle. And the project scope is the efficient allocation of management of resources, commitment to laws and regulation authorized and transmission line project. The goals achieved is to acquire a detailed understanding of various stages of infrastructure development in West Malaysia. Let's move to the next slide. Is the problem statement. There are necessary problem statement which are faced by in the construction lines in Peninsular Malaysia, which are complex specification, technology advancement, environmental impact, risk management, and resource management, regulatory compliances. Moving on to the next slide is the literature review. The technology advancements involved in this project is to monitor automation, use of advanced system for real-time monitoring system, environmental consideration, sustainable practice implementing methods to minimize environmental damage, importance of energy transmission, sustainable development, key to supporting economic growth, and stakeholder engagement, involving stakeholders in planning, execution to ensure their needs and concerns addressed. Next slide is the objectives of the project is to understand the process and construction, project management skills, environmental technological insights, and energy infrastructure management, and demand is to fulfill the demand. So since this is a metropolitan city, the transmission line from Rawang to Kuala Lumpur is to ensure the project of 275 kilowatt overhead line with 1000 megawatt capacity meets the growing power demand to support the community living in metropolitan city, and also to support the industrial growth. Okay, let me pass to my next teammate. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Noran Fatiha binti Norazman. Matrix ID is 211291021. Okay, so let's go through for my part, which is 4.3, project planning and scheduling. Okay. So let's refer to table 4.2, which is the sequence of activity for the transmission line project. So for this table was given as for the task complete in this project. Okay, so the project schedule utilize the activity on arrow AOA approach. AOA visually represents task sequencing with arrows for activities and nodes for milestone. This method promotes efficient collaboration and ensures timely project completion. Okay, so next for 4.3.1 part, which is calculation of expected time (TE) for activities using the AOA method. Okay. Let's refer to table 4.3. This is the chronological sequencing and time estimates of project activities. Okay, so the table outlines the sequence and timing of project activities, including the start and end events. Okay, so next we go to the 4.3.1. This is the calculation of expected time (TE) for activities using AOA method. Okay, so let's see from the activity A until P. This calculation was made by using the formula just now. TO plus 4TM plus TP over 6. So next, activity on arrow, AOA. Okay, so for this part, number 1, 2, 2. This is, we made it by referring table 4.2, which is, it says that the interrelationships, like a B is dependent from A. Okay, so this is, we made it into the project network diagram, and this is how we complete the task for project network diagram. So that's all for my part, and thank you.
Good day everyone, my name is Navanida Analaki Toyraj. My matrix ID is 211291020. I'll begin the presentation with the critical path analysis and project completion time. The critical path method, or CPM, is a crucial tool for determining the sequence of essential steps required to complete the project. Here we use the activity on node or AON approach to visualize task relationships and identify key dependencies, ensuring timely project completion. As shown in the diagram above, the total expected time TE for the project is 75 weeks. We've identified 4 possible paths, which is path 1, A, C, E, G, H, I, and P with a TE of 73 weeks. Path 2 is A, C, E, G, J, K, and P with a TE of 72 weeks. Path 3, A, C, E, G, L, M, and P with a TE of 75 weeks, which is our critical path. Path 4 is A, D, F, H, I, and P with a TE of 62 weeks. Longest path A, C, E, G, L, M, and P is the critical path determining the project's minimum completion time. Now let's move on to the second slide, which is calculation of standard deviation TE for activities using the AOA method. Moving on to the calculation of standard deviations for activities using the AOA method. To understand the variability and uncertainty in our project timeline, we calculated the standard deviation for each activity. The formula used is sigma equals to TP minus TO divided by 6, where TP is the pessimistic time estimate and TO is the optimistic time estimate. In the table shown above, we have calculated the standard deviations for various activities. Highlighting these values help us identify activities with higher risk based on their standard deviation values. This approach allows us to better manage and mitigate potential delays in the project. Now let's move on to the project completion time and confidence interval. For this, let's discuss the project completion time with confidence interval. Our cumulative expected time TE for the project is 75 weeks. With the event standard deviation of 4.04 weeks, we aim to achieve a 99.85 confidence level in our project completion. Using the formula schedule date equals to TE plus 2.97 times by the sigma TE, we determine the schedule date. By calculating the completion time is 87.01 weeks or approximately 20.02 months. This formula helps us to set a reliable schedule, accounting for uncertainties and ensuring that we meet our project deadlines with high confidence. Thank you for your attention.
Good evening, Doctor. My name is Dinesh Raj Anlaki Govindaraju and my metric number is 211290996. Today I'm going to present about the cost of project. Each tower has 4 basements. Therefore, 800 holes need to be digged. Type of transmission towers chosen is LST, which is 4 feet wide and 25 feet deep. And in cubic, it's equals to 11.32 meter cube. Now I'm going to present about the crane cost. The total unit of crane we have used in this project is total 2. So each crane cost is 1,200,000 ringgit. So the total cost is 2,400,000 ringgit. Then next is I'm presenting about the total cost. So total of 7 types of cost we have faced in this project. First is material cost, second is detail engineering cost, construction cost, labor cost of asset cost, heavy manufacturing, heavy machinery and maintenance cost and other costs, and the total cost that we have faced in this project is 76,517,600 ringgit. Finally, I'm going to present about the depreciation. First year is 533,333 ringgit, and the book value at the end of the year is 1,866,666 ringgit. And for the second year, the total depreciation up to 800,000, but the book value at the end of the year is 1,600,000.